Hello, welcome back to the continuation of lesson 32. In this section, 32.1, I'm calling it, is about setting up our experiments. Try to make it easy to run the program with different command lines and compare our result with what the C runtime library gives. At least what a particular C runtime library gives, the Microsoft one, which is the one that I have. That's all I have available. So that involves printing things out, and we have utilities to do that. And so I made a few modifications in our main. And now what I'd like to do first is change our point of view a little bit. I've been compiling this thing and injecting it and re-injecting it into this myprog OBJ. And what I'd like to do now is change our point of view and let us think of this as the main program and this as its partially compiled result. Now, it doesn't matter how you think about things, and in fact the inject batch file it just uses the same batch file as all the other batch files that I have. They all use the same one that makes a script and then passes that through the debugger. And the reason for the different batch files is because there are different scenarios. Sometimes you just want to update your program with a little fix. That's what the inject thing is for. Sometimes you want to build a brand new program. That's what the CMAIN.ASM is for. And sometimes you want to incrementally build a program, and that's what the link thing is, C-link thing is for. But they all actually do the same thing. So it makes no difference for me to rename this now to CMAIN.OBJ, which is what I'm going to do. So now this is our project, and this is our final result. And these things, well, this thing doesn't really have any meaning. I can delete that. But we'd like to keep this code that was used to build this in the first place. We're going to be looking at that later. So what I'll do is I'll just hide that using the hide feature of Windows. There, it's still there. It's just a hidden flag. Now, this here string.table is some strings that these are things that I might want to print out during the testing. For instance, the first test is going to involve printing out those strings. So I'd like to print out this line first, and then the strings underneath. And this one I might use for a pause, or something like that. So as we go along, if there are more strings to add, I'll put them in this table, so I can easily add them or remove them from our program. And I've already added these two in. Now, among other things, well, I added get. And I don't know if you remember, but we built that program a long time ago when we started looking at the uppersync, and I just happened to find it from long ago, a tiny little com file, and so I injected it. It's managed to squeeze it in here right after all the string stuff, and so we have the get feature. Here I've defined something called string table, and what I've done is I don't need to actually define this. It's main plus 4. But I defined it anyway just to make sure that everything is lining up properly. Maybe I'll get rid of that because it's really of little value. All these bytes are a call to 1100. Okay, and generally speaking, if you want to list your data and strings at the top of a function, like the way I have here, which is what I want, you put a jump or a call that pops over the data to something else. I could modify this thing to call a different function, but I won't. In the end, I won't have access to this. We only have this here now because we're looking at the startup process. So that's one way to do a data thing. There are other ways. If you look at the way the C compiler does it, it's actually not too dissimilar from this. Except that the data itself is in a different segment. It wouldn't be compiled in with the code like this. Now, I generated this table, by the way, by just using debug and opening up that text file in debug and dumping out the bytes. So that's why I wanted to have them in a text file. Okay, other changes are the dumping function. I reduced that to just a single call that takes register arguments, so no pushing and popping. And there's a little thing I added for printing strings from this table that I'll get to later. So as this is, even though I haven't compiled it yet, it should work. This is the print and string. I'll get to that in a minute. So let me just go through the normal procedure. Let me back up first, if you don't mind. Alright. Get rid of all that. Now, okay, so now that we're viewing this as our main project, we use the C link, and that's it. You see, when you're using when we're considering this as our target, I don't need to specify anything more than the name of my program. So that saves a little typing as well. Okay, now you see, now the reason I put this symbol at 1100 here was to make sure that there are no mistakes, and you can see that it is at the correct address. We can't tell exactly. We can tell that this number is correct because we get the same number here and here. And the utilities are far, far away at 1500, growing in a downwards direction, which I'm not sure if I should do it that way or go the opposite way or what. I think it's better to put things on the end because, well, maybe it's not better. I'm not sure. Hard to say. Yeah. It might be better to do it. I don't know. Either way, we got lots and lots of space. Now I have to change this to say CMAIN. That's our new project name. If I type go, okay, it's the same as before. It should still work. This is using the new debug print function, which doesn't require all those arguments. You just set CX to the number of bytes you want, AX to the offset, and run the function. It just saves a lot of typing. Here again, our parser, jump to 1,000, which now this is a call off to 1100. And I use a call because the call instruction is always E8, and there's always two numbers. If it's a jump, there's several. Even if it's unconditional, there's more than one variety, and you don't know which one you get until the end. This you can be sure of, and I'd rather be sure. This is a carriage return, I think. Carriage return. Oh yeah, now I'm going to use that same thing he just used to print out the data for the parsed data as before. And carriage return, and then 20 bytes for 440. Okay, same as before, and return, done. And now our program is called CMAIN, which does, if I don't type anything, does that. Now I had in the command history, oh here it is. We change this to CMAIN. Okay. Now, our task, or one that I mentioned that I'd like to do, is print out all of these strings on separate lines. Now, how are we going to go about doing that? Well, let's just have a look here. As it turns out, we know these values. We have them in our header file. But in general, these would not be passed in. We wouldn't know what argc store is. That would have to be passed into our function, as they are in a regular C program. And you would retrieve this value from the stack, and you would retrieve this value as well from the stack. So we could do that, but I guess we don't need to right away. We can just use these two as they are, and then next time through clean that up and add to the stack. So so what do we want to do? We want to first see if there are any arguments in the argument list. Instead of doing all this printing now, I'm going to get rid of that, and I'm going to get rid of this one. You might need it again. Okay. And If there are none, so I guess we could add here move into, well, CX is the natural register, the value of our C, and see if that's 0. And if it is 0, we want to return. Otherwise, we want to do our thing. So what I'd like to do is, since we haven't been passed anything, it's quite easy for me to just hop over this return instruction. I mean, if the value is 0, I would like it to fall through and return. And jump 0, I'm starting to know these by heart now. I'm pretty sure it's 75. And in that case, oh, not 0 is what I want. I think it's 7. If I know it's 74 or 75. Oh, I got an example down here. $74 must be 0. So 75 is if not 0. And if it's not 0, I want to just advance 1 over this return. Now, why am I doing it that way? Because I don't want to add a new label. Okay, so that's jump 0 to IP plus 3. So here's IP plus 1, 2, 3, and that would leave us on this line. So at this point, CX is not 0, and so we can start a loop. What we'd like to do, if we want to use a label now, is kind of a while loop. So we want to retrieve the value of one of these pointers. So we want to move into something like BX, let's say. This thing. The pointer to the pointers. Okay. And now we have, in CX we have this count. So what we'd like to do is go from 0 to CX. So maybe we can use, what should we use for that? Let's put, instead of BX here, let's call this SI maybe, and use BX. I think for a minute have the best way, because not all of them are good with the brackets. So essentially we're going to have a pointer. We're going to be adding something to this and then dereferencing that and then printing the string. So SI, I can add stuff like BX plus SI. Okay, so let BX be equal to 0 at the beginning. You can do it up here. I can do that way up above here. So BX is 0. Okay. And now what we'd like to do is move into, let's say, AX, which is typically the value I'm using to parse data functions, the value of si plus bx, which I'm going to keep adding 2 to, and I'm not actually going to use cx other than for the loop counter. Loop to this label here that this guy would have jumped over. I'll give it a label. Next string. Eventually we're gonna print something out here. Even if we don't use the labels in the end, it helps to clarify what you're doing. So now when cx is 0, this is going to fall through and return. That's what we want. So now we're guarded against that. The Vx starts out as 0. So our V pointers plus 0, the star of that in C language is a pointer, and that pointer points to a string. So now I can use this putS utility I wrote, which takes AX as an argument, and that's it. So we just call putS, and that'll print out the string plus a carriage return. Okay, and now we want to add 2 to BX. We're not multiplying anymore. We're going from, because we're not using the CX index. We know that every two bytes there's another pointer, so we just add 2 to BX and loop to the next string, and that should do it. Now, I wonder if we can figure out how to not have to have this label. How many bytes do you figure we got here? Well, we don't need to do this more than once. Okay. Now I know call is 3 bytes, and add is 2 bytes. 1, 2, 3, that's 5. And this is probably at least 3 or 4, maybe 8. Doesn't matter. We'll just give it a number, and we can work it out later. This is the way I usually do things. We're here in main. Next string, well, it's bigger than 1100, so let's make it 1105. It doesn't matter. We choose any number, and then we'll see from the build what it actually should be. So let's see, assuming the build doesn't fail on us. Okay, so far so good. There's our strings that we're not using. Now, see, this isn't lining up. See, this says 1105, but it should be 11OE. So we can just change that. Try it again. Okay, now this lines up correctly, and that's it. Now, let's think about this now. We start at 0. We find CX, the value, and that's a looping thing will always decrement CX and fall through when it's 1. If this is 0, you can't tell from this printout, but it's going to jump to 110B, I believe. If it's not 0, I should say, it's going to jump to 110B, otherwise it's going to fall through and hit this ret. Okay? And then, if it does get in here, move into AX, source index 440 is the right number, and that's a string, call 1500, and 1500 is a little printer. So it looks like that should work. I guess I can do go, and I'll go to 1000 first. Let's see if we got everything right here. Here's the XOR. Here's the move for CX. That looks right. Checking if or CX sets the 0 flag if CX is 0. If and only if CX is 0. If it's not 0, this thing says go to 110B. And that's where the move is, otherwise we turn. So that's correct. That didn't require a label. And in fact, 110B, no, I think it's different. Not 110B. Okay. Now, we call this, we add 2 to our pointer. If we're supposed to loop, we'll loop. And we should be printing out those strings. So let's see what happens. CX is A, 10. Is it 0? Is it not 0? No, so it jumped. And SI is 1440. And now into AX goes the value 240. Now this 1500 thing prints a string. And there you can see we printed the word this with a carriage return. Now we add 2 to BX. Okay, we loop. Oh, I hit proceed there. Well, what I meant to do was trace. When you hit proceed on a loop, it counts all the way down to 0. And as you can see, it did do what we expected it would do, printed out all of the arguments. And it quit normally, and it's made a conf file. Oops, I want that command line. Okay, so that also tested the null situation. It didn't print out anything. Okay, now let's see what a C program would do with this. I always use small letters for C. We'll call the C one main. So that's the argc, and then pointer to pointer, argv. Now to make it similar to what we have, this would do something like for some number I equals 1. Our thing doesn't print the 0th, or doesn't pass the 0th argv, which would contain the name of the program. So now we're going to test to see if argv is 0. If that's got to be non-null, and I has to be not equal to argc. right? I less than or equal to argc. No, I think it's less than, because argc is always at least 1. So we're starting at 1, and if there's nothing supplied, it should not go through the loop. I think that's correct. Now let's print out argv of I. And the loop's done, we'll return. Does that sound right? I equals, so if let's suppose argc was equal to 1. In that case, it comes in I equals 1, argv of 1. This test should come first, because we're not allowed to check argv of 1 if I is equal to 1. So if I is going to be less than rc, this condition will be false. I will be equal to argc, so it won't print anything. Now suppose argc comes in as 2. Then we go I equals 1 is if I is less than 2, so that's true, that's a true condition, and argv of 1 equals to null. That won't be false, that'll be true, and so it should print out argv of 1 and then just the 1. I think that's the same program. Oops. Okay, let's try it. Let's try it like this. All I gotta do is get rid of this letter. Okay. So this is what the output is supposed to look like. And in fact, that's exactly what I would have guessed it would come out like. Why? Because the rule that I've been using as well, and that I believe should be used, is it goes from tokenizing to not tokenizing every time it hits a quote, in which case it copies everything. And then when it hits the next quote, it starts going to tokenizing again. And then when it hits the next one, it alternates. So here there are 3 quotes. So you're going to get 3 tokens for this, 1 token for this, and then now there's a space, and then now this quote is not a token, it's not a space. So everything following this quote is going to be included as a single token, and it starts, actually that particular token starts here. So it should continue to the end, including everything. This is sort of open, it'll read to the end of the command line. Now a way to improve this output, would be to put something around this so we can see how far it's writing. Maybe we can use printf instead. And suppose we do put a bar or something, and then the token, and then another bar, and then a carriage return, something like that. Now that will at least show us, if we can't see the spaces, how far it's going along. So let's see what this shows. Okay. Now I'm curious, if I add spaces here, I expect them to be included. I expect this bar to move. And it does. Okay. So you see it keeps it's just in the state where it takes everything once it hits the final quote. So we have to emulate that. Another thing that we have to emulate is this behavior. You see, a slash on a quote becomes a quote. Okay? So now what that's done is it's removed the quotation feature of this quote and turned it into just a plain quote to be printed. And now this becomes a token that must include the word sometimes. And then these three things turn into tokens. So we got to do that too. And our thing is doing, at this point, which is not attempting to do anything, nothing, okay? Everything's a separate token. But we're going to use this function that, although it prints the wrong answer, just as my debugging thing printed the wrong answer, it's a predictable, 100% reliable function that always does exactly the same thing every single time. And we're going to take advantage of that fact and make it do what we want it to do. In just the same way that I used that number manager to make that byte lob thing or whatever, write out bytes function, write the correct answer by feeding it data in a way that made it behave the way I would like it to behave. Now, hang on a sec. Okay, that's 37 minutes, which is way too long. But we're ready now to begin our second experiment. I'm going to add in the second bit, and we're going to step through it slowly and watch what's going on and how we're going to turn this output into this output. Okay? All right. See you next time.